between an arithmetic sequence and a geometric? We just covered arithmetic not too far back last week. But in like Algebra 1, what was the difference between arithmetic and geometric? How could you know by just looking at it?
Well, arithmetic is adding and subtracting.
Good. Today's going to be what?
Geometric.
Which it is? All right. And I won't even say, let's just go with an arithmetic. For arithmetic, if it's dropping by 4 like this one, the first term, 18. I agree. But the common difference, don't say 4. It's, Tommy said adding and subtracting. And that's what you're going to see. But when you define your common difference for your formula on a certain problem type, you need to make sure you're always thinking adding. Right? I don't want to tack subtracting on there because people say, oh, you're subtracting. Subtracting what? 4. You're adding what here? Okay. The common difference is -4. Okay. Similarly, for today, geometric. I want to say multiply to get the pattern going. You might see divide. Let's put a divide up here. If you get 24 and then you get 12 and then you get 6 and then you get 3 ... It's not dropping by 12 and dropping by 12 and dropping by 12. That would have been arithmetic. It's doing what? And there's only one way I want you to say it, even though there's 2 ways you could say it. Okay? First term, 24. Instead of common difference, it's common ratio now. But I don't want to hear 2. You're timesing by what? Good. You're timesing by 1/2. Just to clarify. This is an add deal. It might look like subtract, but that's an adding of a negative. This is a multiply deal. It might look like divide, but that's dividing by a fraction. Or excuse me, timesing by a fraction, right? For geometric, you will see some that do this. 80, -20, 5, -5/4. I feel something going on here, and it can only happen on geometric, and that is the signs are changing. So, thought. If the signs are changing, that means the common ratio is negative. Okay. First term, +80. Common ratio? What's common ratio here? We just said if the signs are changing, it's going to be negative. Well, they're changing, ... And now going back to what we just talked about there, you're multiplying by what to build the pattern, to build the sequence? You're multiplying by a -1/4. People like to say divide by 4. That won't work for the formula. If I asked you for the 200th term of this, those people who say divide by -4 would get it probably wrong. Timesing by -1/4, that'll get you the 200th term, no problem. All right, so let's put the generic formulas up here. They look a lot alike. Arithmetic, to find any term, you take the first term and you add the common difference. That's a times. 1 less than the term you want. So if you're trying to find the nth term, there will be an n-1 times to that common difference. If you're trying to find the 100th term, what's going to be here? 99. And that looks really close to today's. To find the nth term, you take the first term. Instead of adding the common difference, you're timesing by the common ratio. And instead of having the n-1 multiplied to it, it's now the power of it. They look a lot alike. But basically, the add has bumped up a level, and the multiply has even bumped up a level. say using the formula to find the 200th term, this is the formula that I'm talking about. Arithmetic we've covered. Geometric is going to be in there today. We haven't done any examples, but there's where we've been, where we are. Negative alternates it. So I saw a trick, it wasn't a trick question, I saw a question the other day on some test, it wasn't our test. It went with a sequence, it went positive, positive, negative, negative, negative. Now there was a number pattern to it that you could see, but the signs went plus, plus, minus, minus, minus. Is that geometric? It can't be. Even if it's doubling every time, right? You say, oh, that's geometric. If the signs don't alternate, it can't be. You can't go 2 positives and then 3 negatives and still be geometric. So don't get tricked by that. Okay? The rest of it's going to sound very familiar compared to the arithmetic lesson that we did a few days ago. Find the 5th term. We've given you the first term. Okay, I know what's going to go here. First term is -2. Common ratio is -3. Cool. And by telling me you want me to find the 5th term, I'm going to have a 4th power. All right. Example 1. To find the 5th term, a sub 5, take the first term, times it to the common ratio, which was -3. What are you expecting right now? As soon as you know the common ratio is negative.
It's geometric.
Say again?
It's geometric.
It's geometric because of the times. What about the negative? What's that going to tell you when you get done building anything? The term should change signs every time, right? And then my power should be 1 less than the term I'm looking for. I'm looking for the 5th term, 4th power. 5th term, 4th power. Well, what do we have to do here? Because some people will type that in and get the wrong answer. We want a times first to do a power first. Please excuse my dear Aunt Sally. We got to do the power first. Forget the 2. Do the -3 to the 4th power, which an even power will make a negative into a positive. The 5th term is 162, and it's positive. Crap. The first term was not positive. All right, let's tweak it. First term was negative. First term was negative. Then my answer is going to be negative. So the -2 has nothing to do with that 4th power. Just the common ratio does. Example 2, geometric means, we had arithmetic means. Trying to keep the gaps consistent. It was on your vocab the other day. Geometric means is the same look. It's 3 blanks between 4 and 64. 4, mean, 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 64. So it looks the same as far as the setup as arithmetic, but the process we're going to get them isn't going to be quite the same because it's a different formula over there. Process is going to be similar, but not the same formula. We know the first term. Second, we don't know, don't know, don't know. We do know the 5th term. If we were going to find the 5th term, we would take the first term times the common ratio, r or CR, to the 4th power. Well, I don't know my common ratio yet, but I know the 5th term, and I know the first term. If I can just get the common ratio, I'm ready to build the other 3. How am I going to get r alone? Move the weak crap first. What's weaker? I know there's only 4s to move. Which 4 is the weak one? Sky, which 4? The multiplied 4 or the power? Which one's weaker according to, please excuse my dear Aunt Sally? Which farthest down? Right? We're going to move this multiplied 4 because it's weaker. 16 is what my common ratio to the 4th power is. How do you want to do a 4th power? We don't want to say square root, but we do want to do a root. Which root? 4th root. And the 4th root of 16 is nicer than some people might think. Well, now now that I know my common ratio is positive 2, what's 4 times positive 2? Times positive 2. Times positive 2. So the answer is not the whole list, it's what's the 3 means to keep my growth going geometrically instead of arithmetically. This is very similar to the process we would have used a week ago. But this would have been an add, and this 4 would have been times. First formula. Process similar, formula changed. Find 2 geometric means between 2 and 1/4. I want to do that because some people will freak because of the 1/4. 2, 1 mean, second mean, 1/4. Get my signs right. This is example 3, flip it. Yep. Both are positive. I still don't know for sure, right, until I think about this. If that's positive, this would have to be negative. It's not. My common ratio better be positive here, right? Cool. I know first term, second, third, fourth term is the only other one I know this time. How would I build the fourth term? I would take the first term times the common ratio to the third power. Well, I know the fourth term, and I know the first term. I need the ratio. Now, Sky talked through it. The 2's weaker. We're going to move the 2. Divide by 2 times by 1/2, same thing as dividing by 2, since I had a fraction over here. 1/8 is what our cube will be. How do I get rid of a cube? Cube root. And people say, well, I can do that over here. I don't know how to cube root 1/8. Yes, you do. Just cube root each piece. The cube root of 1 is 1. The cube root of 8 is 2. You do know that. Well, now I can build the rest. What's 2 times 1/2? 1. What's 1 times 1/2? 1/2. And now my pattern's consistent. Divide by 2, divide by 2, divide by 2. Cool. What's the answer? This is the boxed answer. That's what they asked for. What do you know about example 4? Just looking at it. You don't know the common ratio yet, but you know something about the common ratio instantly. What? Got to be a negative. Your common ratio better be negative on example 4. And it must go negative, positive, or could it go negative, 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 negative? Yeah, we don't know which. It might go alternate, but if it doesn't alternate signs, it's going to be negatives all the way through. Right? So, could it be a negative ratio? Yeah. Could it be a positive ratio with a negative first term that you've got? Yeah. So we have a 50-50 shot here, and look at what happens. You get 2 options because of that. Okay? Things to remember. When you do an even root, square root, there's 2 answers, positive or negative. When you do an odd root, this one, right, there's only 1 option. Let's go back and adjust example 2 then, because I forgot about part 2 of that. When you do an odd root, there's only 1 sign for it, 1/2. Cube root, odd root, 1/2. When you do a 4th root, or 6th root, or 8th root, or 10th root, or square root, there's 2 options. So we've done our positive version. What if the radius was, or what if the common ratio was negative? Then I would have what, and what. What's 4 times to the negative 2 version? Negative 8 times negative 2, positive 16, times negative 2, negative 32, times negative 2 would end up with this positive 64. So even on example 2, there's 2 options. Even root, 2 options. Odd root, just 1 option. Perfect. 91, we're trying to get as close to the test as we can. I think I pretty much got this test memorized. Hopefully you do too. Let's do it. We know, without even looking at the test, there's gonna be a number 2 problem, a 3 problem, a 7, 8, 9, that's our new stuff. There's gonna be an 11 on there. There's gonna be a ellipse or hyperbola. This time they went with, we'll go with 14, 17, because that will be on there. 18, we will be on there. Number 20 will be on there. Show problem, let's go with 23, will be on there. Solve a triangle in some fashion, 24. 26, distance between a point and a line. A little tricky on 27, but some type of problem like that will be there. And then a 29 log problem. All right, 4, as I said, 9, 10, 11, 12, 15, perfect. Last thing you need to get is this, bro. Just flash it for a few seconds and call it good. Those guys that are gone speaking today. 1, 4, 13 through 16. Whoops, wrong lesson. 2, 3, 7, 8, 9, 11. 14, 17, 18, 20.